Hello, and welcome back to another episode of the Networking Podcast. We're changing tracks back to the world of acquisitions and technology news, namely our Expedited Forwarding series. So if you've been chilling into best effort, this is going to be a bit of a mix-up. We're digging into some stuff that's happened recently, acquisitions as we've stuck to so far, and we've got a few that have recently happened that are pretty interesting. But before we dive into that, let's do some brief introductions. So, I am Bruce Wallace, one part of your amazing co-host duo here today.
And I'm Juan James,
who is the other half of the co-host duo. And we are very, very happy to be here today talking about three acquisitions in particular that have happened in the last 2 to 3 weeks. We've been stuck on best effort for a while, so we let them simmer for a little while.
Behind. Yeah, we're a little behind on some of this news. It's not breaking news, it's just news.
Indeed. So if you've already read all the articles, maybe this isn't super interesting for you, but we're going to add some salt and pepper in the form of our opinions. So hopefully that stuff will be relevant for you. So without further ado, the acquisitions we're going to be discussing today, if you haven't read the title, because I'm sure they're probably going to be in the title of the podcast, are Juniper acquiring 128 technology. I think we'll spend a decent amount of our time on that today. AMD acquiring Xilinx, going head-to-head with Intel and Nvidia in the data center market. And Marvell acquiring Inphi, who we're probably not going to spend too long on, if truth be told. But
it was a big financial deal, but I don't think either of us have much of an opinion as to whether.
Yeah, we're not smart enough to talk about hardware.
we lack intelligence. We'll stick with software.
We do indeed. All right, so let's dive into Juniper and 128 technology first. So I think before we talk about like the acquisition itself, maybe it's worth talking a little bit about the history of 128 technology. So, and what they were trying to do. I think, all things considered, these guys were founded in 2014. It's now 2020. So 6 years later, they were bought out for $450 million, which
Correct.
is... I mean, that's like
a good amount of
stellar.
money.
Yeah.
And they had raised apparently over 96 million up until this point.
I see. It's pretty impressive. So founded in 2014. I think the last series was in September last year for around 30 million or so. So they had come out of kind of a first round of funding. 120 employees, 300 customers. I think they're based out of Boston, I want to say.
All right.
I think I remember Boston.
I have no idea, but that sounds right.
Okay. They're definitely based in Boston then, all right?
All right, let's go with Boston.
And 120 million in annual revenue. And I think, maybe this is partly my fault. I don't know how you felt about this, but when I started doing research into 128 technology, never heard of them before, right?
I think I had seen them on like a slide somewhere, but yeah, I didn't know much about them. Also, you said 120 million in revenue, over 300 customers.
Yeah.
I guess. Okay.
Yeah, exactly. 120 million annual revenue, 300 current customers, 120 employees. So I guess we dived into some of the details of the acquisition there anyway, but just to recap, this was a $450 million acquisition. The second kind of AI acquisition that Juniper has made in the recent history, following their Mist Systems acquisition back in March 2019, which was for around about the same amount of money, about 400 million.
Yeah, but you know what's interesting there is that if you read the press releases and all that jazz around it, there's a lot of mention of this being AI based, AI focused. But when you actually look at 128T, I didn't see very much in terms of anything related to 128T specifically being very AI related. And they may be able to integrate it into Mist and integrate it into some sort of AI system that Mist is currently using. But if you just separate that and look at 128T and what they do today, I didn't see much in terms of AI. So there was a lot of buzz around this being an AI acquisition, like you said, but I'm not really sure
That's a good
whether
point.
It should be.
Yeah, it's a good point. I mean, my notes just say AI/ML repeatedly for a whole page.
That's
So-
because that's what the press release said. Because if you read the press release, all they said was, this is in addition to Juniper's venture into the AI space and bringing AI to the campus and
Yep.
to a bunch of their product suite. So, and this was yet another piece of the puzzle, let's say, which I guess we can talk to in a little bit. But 128T itself doesn't seem to bring any sort of AI to the table other than feeding in more data into the Mist AI system potentially.
Yeah, you make some good points that I cannot contest, so I won't try. I will say I was joking about AI ML everywhere. I absolutely agree with what you just said. When I was going through, because whenever we're doing this kind of research, you always start with the press releases, right? Like what are the companies saying about the acquisition? And it was all AI ML, AI ML, AI ML. And then when I actually started looking into 128T as a company and looking into kind of the technology that they've built, that they've distributed to 300 customers, didn't see much AI there. In fact, it's not mentioned anywhere in kind of the on 128T part of my notes. So absolutely agree. I think maybe, marketing hype is marketing hype, right? Like we like to use words like intent. We used to use SDN. SDN is old now. Intent's the new SDN. AI and ML is the new network getting smarter. And telemetry is just the bee's knees. We all like telemetry. So
everything is exactly.
Probably a bunch of marketing hype. I can say that the market didn't seem super impressed with the acquisition, at least off the bat. If I just go and look at share prices and all that good stuff, they took a slight dip in trading on the day of the acquisition. Well, when it was announced, and they've been down about 10% since the acquisition was announced. Now, obviously, that's not all based around the acquisition, like, market fluctuations being market fluctuations, but they certainly didn't get a bump from the acquisition. Maybe
right.
The market's not appreciating Juniper's buying spree.
I have no idea. I don't know. Or maybe the market didn't really see where this fit in, and maybe we can talk a bit about where we think it fits in into their solution and why they would have spent this kind of money on something like 128T.
Yeah, I think this is a good segue into talking about the technology itself. So, for one, it did seem like at least a lot of analysts had kind of analyzed, for lack of a better word, that this was kind of an approach for Juniper to break further into kind of the edge/campus SD-WAN market. And we'll go into a little bit around like 128T and what they're doing. And I know that we're going to end up going down a rabbit hole on discussion around session-based routing, because that's really kind of the heart of their technology. So I guess, what was your first impression when you started reading through this? Because I didn't want to...
Well, the first things that I read originally was that they were trying to revolutionize routing with this session-based, well, what do they call it? Vector-based?
Secure vector routing.
Secure vector routing, which is a term they coined, and session-based routing. And if you look at their original, a lot of the stuff they published early on when they came out with this idea is they wanted to kind of revolutionize the routing market, and not just, from an SD-WAN perspective, but like they just literally wanted to be everywhere, and they didn't want to be seen as an SD-WAN vendor. They really wanted to be seen as another routing type of vendor. And then I think what must have happened as they went through the motions of trying to productize this is they realized that what they actually did well, which we'll discuss shortly, really suited itself to more of an SD-WAN type topology and not necessarily a traditional router market. And especially they had and they still do in some of their white papers, talk about use cases for the data center, and then it becomes a little bit murky as to how and why you would use something like 128T in a data center. But yeah, so from my perspective, it really seems like SD-WAN is the logical place where something like this makes sense. Even though they tried to position themselves, and they, especially early on, they really tried to position themselves as something more than just an SD-WAN vendor. They really wanted to be a router vendor.
Like they wanted to revolutionize routing, right? Like
that was the goal. Yeah, exactly.
So I think let's pause there for a second and talk through what it is, right? Because we're starting to already go around the analysis of what it is part. So essentially, 128T has a technology that it's all around this thing that they call the Session Smart Router. And what this really is, at least from a white paper, the research that we've done, is the ability to route packets, I guess, based on session context instead of things like LPM and LEM, which we typically use in routers today. And there's a reason we do that, which I guess we'll get into in a little bit. But the whole idea is that they've reinvented routing. They've brought it up a layer. It's no longer at layer 3. The network needed to adapt, and lots of marketing buzzwords around revolution. And all it was really is that they've created a way to kind of distribute session awareness across the network and to be able to almost do some kind of like segment routing implementation, which I think you did a decent amount of research on, this whole waypointing system. To get traffic from point A to point B, they created their own protocol called the Service and Topology Exchange Protocol, or STEP.
Yeah.
And really, this is, like I say, it's almost like a flow-based data plane, and trying to position that as kind of a router-based data plane. Which, yeah, I guess we can start the speculation now and the opinion piece. Which, I think there was two sides to this that I actually kind of like grinded my gears, so to speak. One was all the stuff you just mentioned around how they were trying to position this as kind of like revolutionizing routing, and a change was needed. The network hasn't been evolving and adapting as quick as the surrounding ecosystem, which is absolutely true. I don't think there's any debate in that. But that the idea that the way to do that was to bring things up a level and to route things based on sessions, there's a reason we don't do this, right? And it's all to do with scale. Like, it's all to do with scale. It's also the reason why I think you've kind of correctly identified that's why they pivoted towards kind of this whole SD-WAN thing. You can do that if you're at the edge points, but the idea of, like, imagine having, your PE within your data center, routing things based on sessions.
Yeah, well, the biggest thing, one of the big challenges there is, and they ran into this obviously, is that if you're using something like all these proprietary protocols in order to do this session state establishment and share that amongst other devices, is that you needed to run 128T everywhere. Devices exactly everywhere, and so you wouldn't be able, you'd have very little interaction with your traditional routing. So it'd have to be from start to finish 100% 128T in order to really make use of this whole being able to route your paths through and optimize your sessions through a network, which is in itself quite challenging if you're trying to end to end use it in a single vendor and a single application stack. In order to do this is quite challenging.
Yeah, agreed. And I think like what they were trying to go for here, and I can at least give them kudos for the vision, because it's a cool concept, and I think if it could be executed at scale end to end within a network, then there would be something here. Unfortunately, I don't think that's realistic. But like the idea that you can apply policy and I guess all of the way we drive traffic in the network at a session level rather than kind of a prefix or like a MAC level or a port level, really having that session context is great. It's why we have flow-based data paths typically at the edge on the compute, right? Like things like Open vSwitch and OpenFlow, all that good stuff. There's merits to that. The problem is purely a scale one. Like if we could drive the entire network like that, then great. But you can imagine having, I think you found a scaling document which talked about it. I did see a little footnote that said up to 1 million sessions, but it was tested around about 128K or so.
That's
when
right.
when you look at kind of a data center, or you could even get this kind of scale in like a branch, right? Like I know you and I tend to do the whole scalable data center, hyperscale. We do that, but even within a branch, I think you're going to be able to blow the scale out of the water fairly quickly. Basically, this all depends on use case, but number of sessions is going up because we've realized as an industry that parallelizing things is a much better approach than just making the pipes fatter and fatter, because we're going to hit like the limits of physics when we do that. So I think that's the bit to me that I didn't buy, right? I think doing this at either end makes sense. Doing it anywhere in the middle is not going to scale.
Right.
Was that kind of your feeling too?
Yeah, I think so. And I think, again, this is kind of even, this is why it lended itself to an SD-WAN type solution, even though, you mentioned you had concerns around some of the branches. Sure, on the larger branches, you may run into this, but there's certainly a lot of use cases in smaller branches where their scaling numbers would make complete sense. And you'd be able to do that. In fact, there's quite a few, I don't know about quite a few, there's definitely a few SD-WAN solutions out there which are flow-based to this day, and they operate. So yeah, I think you'll obviously hit that scale number at some point, but it certainly would make a lot more sense in the branch and SD-WAN space than it would in anywhere in between, like you said, like any PE routers or data center egress points. Like I think you would just blow that completely out of the water.
Yeah.
It would be tough to work with.
Yeah,
but they do some stuff that's pretty cool, right? So they do some stuff with regard. So let's focus on this. Let's just pick the SD-WAN as the use case that they're going after, at least for now.
Sure.
They do some stuff which is pretty neat. One is one of their big claims to fame is getting away from overlays, right? Like they call it overlay sprawl, where basically a lot of these separation of traffic and is done with VXLAN or MPLS or VXLAN over IPsec or whatever combination of those. And that from their perspective, that adds a lot of overhead. That allows a complexity. You have, they would tell you that there's a lot of fragmentation issues and things you have to worry about when you start adding these headers for segmentation. So what they do is none of that. They don't do any sort of overlays. They don't add any sort of labels to the traffic. They do everything is based on NAT. And so whenever a packet egresses one of their routers, it's NATed to that router's egress port interface, basically. So if you're in a branch, that would be like your WAN interface on that router. Everything gets NATed out of that. So there's that's another scale. That ties into the session scale we talked about earlier. But what it does do is, it does get away from having to use all of these different types of encapsulations.
Yeah, I was going to immediately jump on the... Because there's a few reasons we use overlays, right? One of them is, and the obvious one is clearly for kind of micro-segmentation or macro-segmentation, I guess. And that's definitely one use case for it. There is actually another use case, which I think is picking up more and more, is the ability to hide prefixes from the network, right? So, if I have a simple GRE tunnel running from point A to point B, I can have a bunch of prefixes sitting at point A and a bunch of prefixes sitting at point B, and they could be crossing a massive network, and that network need not know about those prefixes. So you can hide things. Right. NAT also accomplishes that with the downside that, rather than simply doing a decap and getting kind of your service context based on a header that is pushed, you're having to maintain session context. Right?
Yeah.
You're having to
and maybe
state.
We should just briefly talk about how they actually accomplish this, because any network engineer listening to this will say, well, once I NAT everything, then I lose the original source IP and destination IP. So how would the far end know what to do with that packet once it received it? So just very quickly, we can talk about how they actually manage to do this. So what they do is when the first packet arrives at your 128T ingress router, let's imagine it's coming from your LAN into your 128T router. It does a lookup to find out where it should be going, what the destination 128T router looks like. So if you're going from branch to branch, what your second branch would look like. And then it stores the originating source IP of the packet, the destination IP, the far end LAN IP packet in a metadata field. Like they have some metadata that they store. And then they fire that off across the network, and every hop along the way. So every hop, by hop I mean 128T hop. So if there's only two devices, the second device would look at this metadata, and then I guess store that metadata information on its device, so that any subsequent packet that arrives, it would know what destination IP to rewrite on top of that packet header. So you don't lose anything with NAT. And it does this on the very first packet for any given session. Any subsequent sessions are part of that flow, essentially. You don't have to carry that metadata. So the very first packet carries an extra bit of data. I think it's like 250 bytes or something like that, which contains a bunch of information, including all the stuff I just talked about. It gets fired off across. Every 120T router along the way inspects the metadata, so it knows where it should be next hopping to, where it should be sending the packet to next, what's the next 128T router. And then the egress point will inspect the metadata, store the destination IP and source IP in some sort of state database of sorts, I suspect. And then every packet in that flow that arrives, it gets that destination IP gets put back on the packet and forwarded on the LAN side. So you don't end up losing that, because traditionally in that you would lose your source IP. In this case, they're transporting it in that metadata field. And this is why they're allowed. They claim that it's much more efficient in overlays because you're not, on the very first packet, you have that extra 250 bytes or whatever it may be, but then every subsequent packet after that, you're not slapping on a header and then forwarding that off across your network.
Oh, I see. So the first packet is basically to set up kind of your NAT context, so to speak.
Exactly. Your session route.
Yeah. So you're more efficient on the wire in that case.
Yep.
But
correct.
The issue I see with this, and again, it's leaning on scale, but lookups against things like flow tables are much more expensive, and they don't scale as well as lookups against like LPM, or I don't want to say LEM because it's kind of the same thing, but at least LPM, like the ability to aggregate basically how something should be forwarded, and you could group together a bunch of different sessions. But I guess the point is that you lose the session context by doing that, and if you wanted to apply a policy and that kind of thing, then you need this information. So
yeah, and I'd like to think that and again, that's coming back to the scale thing, but I'd like to think that in the use case that we've identified, at least what it seems like their primary use case, and hopefully we're not wrong, and the fact that they have those 300 customers and $120 million yearly run rate, it seems like it's hitting a market that's, if this fell apart on the very first time you deployed it and didn't scale, they would never acquire that many customers and have that kind of. So obviously, for whatever use case they've hit, the scale seems to be okay, but I do agree that from a technology standpoint, it's not ideal, and maybe you're hitting a very narrow use case for it, and maybe that's fine. Maybe that's the use case they want to hit, and that's achieving that. But it certainly wasn't the use case they were trying to hit when they first set out, at least from what I can read.
Yeah. Okay. Because I had that exact impression that originally they were trying to reinvent routing, and my immediate thought was, if you don't have 128T routers everywhere, and let's say you have a session,
it's useless.
I mean, it's useless, at least for the parts in the middle, but you're still relying on routing. Like, you haven't reinvented anything. You're just doing something at a higher layer.
Exactly. Correct. Yeah.
Yeah.
And so maybe we can add some more color to that. So they have this concept of waypoints, right? So like we said, they have these 120T routers, and then it's able to look up a next hop from a session standpoint, and the next hop is really the next 128T router along the path. So if you imagine a network where you happen to have, for whatever reason, 20 128T routers between a destination and another destination, and a source and a destination, what you're actually doing is at every hop along the way, on that very first packet, you're looking up that metadata, and then you're looking at what they call a service information base, which is basically a RIB plus some session information, such as dictating like the sort of SLAs required for that given session, if there's any sort of latency dependencies and jitter dependencies and so on and so forth for the application. And then based on that, and based on the information it's gathered, it's able to know which next 120T next hop or waypoint, they call it should go to. And then it goes through that whole process of natting the packet. Next hop is now switched to your next 128T hop waypoint, and then it looks at the metadata again, and repeats that process through the whole set of 120T waypoints or routers. And then finally, when it gets to the far end, it does what I described earlier.
Yeah, I mean, honestly, I'll take back the scale concerns, because at least the NAT is hiding the flow scaling problem if you were trying to do this along every point along the way, right? So it is just normal LPM at various points within the network. This is mainly focused at the edge, where the scale is going to be lower. The idea of using kind of a session or service context along with RIB, I mean, it's cool. Like, I'm liking everything that you just said.
I like the idea.
Yeah. It sounds cool. And clearly it's working, because they have existing customers. This wasn't just a startup that got snapped up before they could go to market. They've gone to market. It appears to be working. So It is cool. I noticed, we just recently did an episode on data modeling. They model the service-centric control plane, I think is what they call it. There's a lot of marketing buzzwords.
Yeah, there's a lot. Honestly, if I read their white papers, it's like 90% marketing verbiage.
Verbiage. Okay.
Verbiage is the word I was looking for there.
Yeah, exactly. So it does model kind of services in Yang. They support netconf and restconf today. I didn't see any GNMI, unfortunately. But
I found it interesting. So you have they have the, that conductor. So they have, I guess, 3 kind of layers to this whole solution. They will have the 122 conductor, which is your management and policy analytics engine, your kind of northbound interface. And then a control, which is like a controller. And they have a slice, which is like your data path, right? So those are kind of the 3 layers to this.
Yeah.
The 128T conductor, which is your management plane, like you said, they have a data model for that, which you said is very service centric. But I was very surprised to see that netconf was one of the available configurable parameters. After our last podcast about netconf versus GNMI, it didn't seem like netconf was really like a northbound interface. I mean, if you're gonna have you can have a RESTful API, it kind of makes sense for that layer.
Yeah.
But netconf, like, does that really? I mean, it seems like an
exactly.
odd interface to have at that layer. You know what I mean?
Even having GNMI at that layer would be strange.
Wouldn't make sense. Yeah, it wouldn't make sense. Correct. Yeah.
Yeah.
And then they have when they get down to the controller, what they call the 122 control layer, they have yet again interfaces. RESTconf, netconf, or they have a REST API, netconf, and they even have a CLI, I think, on the 120T control. And I think the data models are slightly different at this layer because they actually do have to model traditional networking stuff like OSPF and ISIS at this layer because they may need to interwork with, routers and understand, what that may look like. What a next hop. Yeah, exactly. And so they have yet again another interface and another data model at that layer. But I didn't quite understand the relationship between the conductor and the control plane in the sense that if I went and made changes on the control, would that get reflected into my service policies on the conductor? Or, I mean, the stuff I read didn't get that deep into it, but just found it interesting that they had a separate set of configurable data models and interfaces on the control also.
Yeah, I guess this could tie into that whole centralized versus distributed control plane, right? Like, it does sound like the conductor is more of the management, kind of the management layer. So you would write the policies there, and they would be distributed down to the controllers who would then enact the policies on the slices, is how I interpreted it when I was reading through it. So having a management and control separation.
Which sounds very similar to other flow-based SD-WAN solutions out there.
which
I happen to be very familiar with, but
so I guess the policy bit, I guess, is important, right? Because you're right. This does seem to resemble a lot of the SD-WAN implementations out there. I do think they've kind of gone a few steps ahead in probably how they drive policy in terms of sessions, where even if you look at like a typical flow-based data path where you have like a flow, like, your first packet comes in, that hits your slow path, and then you're making a forwarding decision. They've kind of, I would say they've improved on that a little bit with this whole, like, the first packet having it and subsequent packets not having the header. I'm assuming, because none of this can be done in hardware, right? There's no hardware ASIC. So this is all a software data path as far as
it's
I'm
entirely
concerned.
software. Yeah. And they want to leverage like DPDK to punt the packets up to that appliance as fast as they can. Yeah.
Yeah. So I guess maybe I'm even wrong on that, in that first packet is hitting the slow path.
The first packet is hitting the slow path, I'm pretty sure. But that's exactly the same as any, let's say, OpenFlow based solution or Open vSwitch based solution. So like it's exactly the same. The improvements, as far as I can tell, if you're comparing that, is the lack of headers, like having to encapsulate, right? So maybe there's some gains there from so there's some gains there from the in-cap decap perspective. Like you don't have to in-cap decap. I'm not sure what the hit is on the natting process versus in-cap decap, but from my testing previously, that the natting tends to be quite a bit faster. Like natting is a lot easier to do.
Yeah, you're just rewriting a header, right? You can do that pretty
exactly.
quick.
Yeah, and then the other thing that was thought was kind of neat is that if your payload is already TLS encrypted or encrypted at all, you actually have the option of not re-encrypting the payload because if you take like a traditional, not traditional, and let's say an SD-WAN solution that has, it's hard to say traditional with SD-WAN because there's nothing traditional about it. But if you have an SD-WAN solution that's using an in-cap for micro segmentation like VXLAN or MPLS, and then you're using IPsec for security and encrypting the payload, you sometimes and oftentimes end up double encrypting your actual content payload because the applications tend to usually use TLS or something like that, and then you're further encrypting it, right? So one option they have is that if you can identify an application session as already being encrypted, then do not go and re-encrypt the payload. Just leave it as it is and just trust the TLS or whatever encryption you're using on the payload is fine, which is kind of neat. It just, an extra step that's not required basically, as long as you know that the application that's coming through is already encrypted.
Yeah. I wonder if the other piece to this that might impact performance is the whole checksumming, right? So I know with VXLAN, what is typically done is they'll just the checksum is set to 0, and that's legal. Like within the RFC, you don't have to recalculate a checksum when you push a VXLAN header, which is kind of awesome if you're doing this stuff in software, which VXLAN is kind of designed for. With NAT, I don't think that you get the same pass in that if you're changing the header, you're probably going to have to calculate a checksum. So yeah, I think there's a trade-off there. Yeah, there's a trade-off. And they could be offloading some of this is the other thing. I didn't see that anywhere in when I was looking through the documentation, but in theory, checksum offload has been done to like NICs and things like that for a long time. When I'm assuming this is just running on standardized compute and they've got, NICs with accelerators in them. So there is that angle that maybe they're able to offload some of the checksum calculation, but just another angle I was thinking on. So all in all, I think it's pretty cool. I think it's pretty well put together. I think if the pivot to SD-WAN was probably a wise one. I couldn't imagine like an LSR doing session.
No, exactly. So I'm saying it only makes sense at lower scale. Like this is not going to replace your Cisco router. Let's just put it that way. As much as maybe they had ambitions of running entire WANs and data centers running this technology, I can't see it happening.
Yeah, and maybe that was just some marketing confusion, right? Like maybe they had no intention, but the way it was.
I mean, the words are pretty strong.
I watched probably the same video you did. And
I actually didn't watch any video. I didn't watch any
really?
video, but in like one of the early white papers they released, like back in let's say 2014-15 when they launched, they made it extremely clear that they didn't want to be seen as just one trick pony. Like they wanted to really revolutionize the routing world.
Well, I don't know if they've succeeded.
Yeah, no, me neither. It'll be interesting to see what Juniper does with it, though. Yeah, it may be interesting to see what Juniper does with it, right? If they're going to try and tie this into their AI story, like, I could see them collecting session analytics. Like, I mean, this apparently collects a bunch of policy and analytics, and I'm not sure what they do with it. I haven't looked at it. If Juniper could ingest that into Mist AI and then do something smart with it, I mean, there could be something there. I'm not sure.
Yeah, I guess there's the whole you brought up the idea of having SLAs associated with sessions, right? And I think we saw this we saw this at Networking Field Day. There's a bunch of startups and some of them not startups that are focusing pretty heavily on user experience at the forefront of kind of the products they're building, as opposed to kind of being the functional technology, the building blocks and the scale that drives things. So, the idea that you could be testing a flow, because that's essentially what these sessions are, a flow, and measuring the latency on that flow and the jitter, and maybe if there's a better path that has less latency, maybe it's more reliable from a jitter perspective, you could potentially reroute traffic in real time. And driving this through some kind of, like AI ML control plane. I mean, I can see it, especially when it's done at the edge. I could see that. This is kind of that dream we have in the WAN, right? Of doing this using SR and driving this using a centralized controller that is measuring bandwidth on links and rerouting fat flows and stuff like that.
Yeah, but the SD-WAN space, that's pretty common, right? Like in the SD-WAN vendor space, the whole routing sessions based on performance, is pretty standard. Most SD-WAN vendors will do that. They'll have probes out there of sorts measuring performance. Okay. Yeah. That's pretty standard.
Yeah, I
the
have
part
no
that
SD-WAN background at all. Whereas you do, which is good. You're an expert
I do,
on
yeah.
this.
I'm not an expert, but yeah, they do it. So you can do application based performance monitoring, and if you detect that application, which is what these guys would be doing, you have strict SLAs, and then you can route it up different uplinks or different routes based on those SLAs. Now these guys are actually doing, interestingly, they're doing their jitter performance monitoring using BFD. So they must be doing some sort of BFD between their
So
120T
networking
routers.
constructs are fine now, huh?
They're back in business, which actually other vendors may not be doing. But
Right.
also, actually, I was thinking about this more like the topologies in which they would use this. Like again, they like to pitch this whole idea of a bunch of these 120T routers and waypoints and really optimizing the path between A and B through this waypoint. But if you look at the SD-WAN kind of typical topologies, you have your branches. Most of it is like a hub and spoke topology where you're bringing traffic back up to like a centralized location. So you're not going to have like a bunch of these like 120T routers. So you're really only selecting between like which internet provider at your branch or which uplink provider at your branch you want to optimize your traffic over. And then another aspect of it is that if I'm running, say, Office 365 or any sort of like SaaS application, I'm probably going to want to just dump that straight to the internet and not actually do any sort of optimizations, right? And so the use cases tend to like diminish as the more I think about
Once you get into reality.
what space they're operating in and what sort of the use cases look like. This whole concept of natting and routing between all these waypoints, maybe. But the whole like concept of like full mesh SD-WAN is not, it exists, but it's not the primary use case. Hub and spoke is a very common SD-WAN type of topology. In which case you're going to have a hub and then you're going to have a spoke and you're going to have nothing in between that speaks 120T. So
you got one path, baby.
yeah. Well, you may have multiple paths over different carriers or something like that. So you do still need that kind of performance monitoring and the ability to switch paths. But again, you're switching paths between different uplinks out of your SD branch, I guess. Anyway, maybe we're missing something. Maybe this isn't actually SD-WAN at all. Maybe the use case is completely different. But from what I understood, that's what it was. At least I couldn't.
I did too. A bunch of analysts seem to concur with that as well on the few articles I read that this was. I mean, the comments were that Juniper was having a hard time breaking into SD-WAN. They were actually doing well with campus and like through the Mist acquisition, but that the whole SD-WAN piece of it was not something they had filled well in their portfolio. And that this,
I think they tried to hack it on, right? They tried to hack on SD-WAN onto their SRX or, no, it wasn't the SRX. Was it SRX?
I think it was
they have
the SRX.
another. Yeah, they have another hardware platform on which they were running this stuff. And anyway, I think they just tried to kind of bolt it on and put a story together. And I'm not too sure it really took off. So that would explain this. If they're really trying to have a story around analytics, policy management, session-based or flow-based type of routing, then maybe this is where it makes sense.
All right. So I guess general conclusions. Cool. It's another respin on SD-WAN. I think there's a lot of the same fundamentals that have driven SD-WAN through my limited experience. I'm sounding like I know what I'm talking about here, but I really don't. I know a lot about flow-based data planes. I just don't know. I'm more on the data center side, right? So I think there's a lot that is the same. I think natting versus overlays, I'm sure you could pick either side and have a good debate on that. There's certainly merits to overlays. There's certainly merits to natting. I mean, I would tend to lean on the overlay side, by the way, but that's purely coming, again, from that scale angle and that, not having to expose prefixes. You get that with this NAT solution as well, so I guess it's not a full-blown thing,
exactly, that goes away, right? They've solved that with their little metadata field thing. I would be interested in actually, and we'll have to do this maybe, is getting the opinion of someone that we both know in this space.
Yes, we should do that.
Yeah.
We should do that.
It would be very interesting to hear what he has to say. But maybe that'll be a follow-up to this one, maybe, to this episode.
Indeed. All right. So I think it fills a bit of a hole in Juniper's portfolio. I think if they integrate it well into Mist, they're going to have a fairly clean kind of edge/campus solution. 450 million is like 3.5 times revenue. I don't know. That doesn't seem crazy. It doesn't seem.
I can't even comment. I mean, it sounds reasonable. I have no idea. I wish I could speak more smartly about the value behind these acquisitions, but
That's okay. Just state the numbers and then go
yeah,
good, bad.
450 million seems like a good number. I approve.
Good number. Good
Good
number.
number. Good
All
round
right.
number.
All right.
All
So
right,
I
let's
guess
move on
we'll
to the
see
next
how
one.
how it plays out if they can integrate it nicely into Mist and kind of keep their momentum. But
Could be good.
on to the next acquisition, and this one I do want to have a bit of a discussion about because we're kind of got these three titans of data center that are starting to
Emerging.
yeah. So the next one, of course, we stated it in the intro, AMD with their acquisition of Xilinx. So again, let's just break down some of the facts, talk about Xilinx a little bit, talk about the acquisition, and then I think we're just going to jump straight into speculation territory because that's where we like to live. So this was another absolutely massive acquisition, right? I think Nvidia ARM was like 40 billion or something from memory.
Yeah.
This was 35 billion, so they almost got there.
It's crazy.
I think this was AMD kind of cashing in on their stock price because it's been going through the roof lately. Excuse me. So it was an all stock transaction, which is pretty crazy. I think it was like 24% of the total AMD stock is going to be Xilinx or some crazy, like it's a lot. It's a huge amount.
Sure.
I don't know what the market cap of AMD is, but it's pretty crazy. 35 billion is, I mean, that's a lot. That's a stupid amount of money. Xilinx was founded in 1984, so this is one of those old like integrated circuit kind of ASIC FPGA. They actually invented the first FPGA, I believe. I think they were the inventor of the FPGA, which is pretty awesome. They build a lot of SoCs. They build a lot of accelerators. I believe they now have a SmartNIC. So you can see how this starts to fit into kind of the Titans of data center piece that I want to get to. It seems like Xilinx has been in a little bit of trouble lately. I think Huawei was a huge customer of theirs, and they've been affected by the tariffs and Huawei getting kicked out of a bunch of countries based on geopolitics, all that good stuff.
Trumpism.
I wasn't going to say the name. I did my best to stare around it, especially right now. But geez, you just
I like to
laying it
comment
flat
about
there.
the geopolitical landscape as a very proper way of wording it.
Yeah. So Xilinx has their share price is down about 22%, or was because it's just been acquired since spring of 2019. So they've almost lost a quarter of their market cap since spring last year. So they were in a little bit of trouble. AMD, of course, has been shooting to the moon on the back of Ryzen, on the back of Epic. They just released a Big Navi. I don't know if you saw those. We're gamers, so I feel like we can talk about that here. And they're doing a pretty phenomenal job. It has to be said, right? They are kind of like crushing the world. The only real competition that they've got on the CPU space right now is kind of the growing momentum towards ARM. And we saw, if you are listening to this podcast in the future, Apple just released their new Apple Silicon-based MacBooks, which are based on ARM, a design that they've done. So their only real competition, like Intel's not even really a competition for them anymore, other than they've got like massive market saturation. AMD is kind of like on the dominant path. So I think with all that said, there's a bunch of synergies we're likely to see here, both from a general like having an AMD CPU, maybe with like an AMD GPU doing some kind of like a ML learning, along with accelerators on the network side being the NIC. And the main reason we see this is for things like RDMA and for, I guess, NVMe over Fabric now. The idea that you're shipping basically like memory into memory across a network, and if the network doesn't play nicely, then it's the equivalent of trying to like write to a block of memory and having that fail, which most applications, they don't play super nicely when that happens. So I can see a bunch of synergies there. It is worth stating that if we wind back the clock a little bit, Intel made a similar type of acquisition back in 2015 with Altera. It wasn't 35 billion. I think scanning my notes right now, 16.7 billion was that acquisition. And, just recently, one of the first episodes we did was around NVIDIA acquiring Mellanox and their whole Smart NICs, ConnectX and Spectrum. So we now have the three titans of data center. Yeah, we've got Intel with, they already have a bunch of, what I'll call intelligent NICs. They don't actually have socks on them. And now they do have smart NICs in the frying pan, ready to come out. We've got Mellanox, of course, with Mellanox. Why didn't they call their company that? I'll take some royalties if you do that. They're not going to, of course, because they have pivoted out of kind of just being a NIC vendor, but they have their kind of intelligent NICs, which don't have CPU complexes, and now they do have smart NICs as well. Their whole Bluefield line of products. And now we have AMD with Xilinx. And granted, Mellanox has kind of gone the whole ASIC approach for their smart NIC, and Xilinx being an FPGA vendor, it stands to reason. I didn't actually look.
And Intel's FPGA. Yeah, Intel's FPGA too.
Yeah, exactly. So I think there's we've got these three, they're all like massive companies, right? Despite Intel's kind of downfall in the last couple of years, they still have a huge market cap. They still are absolutely dominating data center, at least from a
server
current
workloads.
Yeah. Now that is decreasing, right? Like AMD is just stealing market share from them like hand over fist. So I think unless they pull a rabbit out of the hat, maybe they should have stopped fabbing their own chips like AMD did. But I do see this Xilinx acquisition as being very, very strategic for AMD. And now they can kind of own their end-to-end solution within the data center, both from
at least offer it just like their competitors do, right? Just like Intel does, and just like Nvidia now does.
Yeah, exactly. There's also there was some just one final point before I let you make your comment. There was one other synergy that was highlighted in terms of fabbing, right? Because I think the AMD and Xilinx were both using TSMC. So in theory, they can now join together volume. They can drive down the per wafer cost, and this could potentially result in some being able to shave some additional margin.
Intel should just go buy TSMC.
They should. I don't know if they can. I think TSMC is worth too much.
Yeah. I agree, but can you imagine that move?
I mean,
would be amazing.
It'd be balls. Yeah, they should just go talk to
it's
some
not
bankers.
It's not going to happen. But yeah, exactly. Go borrow a bunch of money and just buy them, and shut the Nvidia and AMD down.
Yeah. I mean, the other one that has a fab now is Samsung. I shouldn't even know. Like, I mean, the fabs that I've always known about have been, I guess, Intel, Global Foundry, and TSMC, because they're kind of the big guys. But Samsung has an 8 nanometer node now. So, yeah. And I guess Apple, the new iPhone, right, was based on that. Or was that? No, the NVIDIA new video card was based on it. The 3000 series. God, there's so many product releases. Techtober has been insane.
I know, it has been crazy,
yeah. So, I think not much else, at least from my side, not much else to say. It makes absolute sense to me. Clearly, AMD is doubling down on the data center effort. It is a market, like they're kind of dominating desktop. I actually don't know if they're dominating desktop sales, but they should be, because they're ahead on technology. I didn't go and look up any numbers.
I don't think they are. But I think they're definitely closed that gap, and they're up there, but I don't think they're dominating.
Yeah. I mean, certainly they're stealing market share from Intel in a pretty phenomenal rate. So, so now going after data center as well, which has kind of been the bread and butter of Intel for many, many years. We're going to see Nvidia start to try and compete there as well. I don't know if the ARM acquisition necessarily is data center related because of the whole licensing thing, right? It's not like other people can't go and make ARM CPUs. So, but having a kind of the whole end to end. And having, I mean, if you're a data center operator today, you've got a lot of choice now. Like, it used to be that you were just buying Xeons, like just massive volumes of Xeons. Yeah. And probably Mellanox ConnectX 3 or 4, because that was, beyond 25 gig, Mellanox absolutely just slaughtered the market, and as Intel fell behind. But yeah, now there's a lot of choice out there.
I wonder what kind of synergies they'll get between these different components in the server, from your NIC to your CPU to your GPU potentially now at this point. Like, you know, what advantage will I get by buying an entire AMD stack versus maybe an Intel NIC with my AMD CPU and my Nvidia GPU? You know what I mean?
Yeah. It's a good question. And before AMD kind of announced their big Navi RDNA 2 video cards, I would have said not much. But we saw with the way they're doing memory sharing between their GPU and CPU that there is some meaningful gains in terms of performance by having both AMD GPU and CPU.
Yeah, exactly. And I think that'll extend probably to the NIC as the NIC gains importance in the servers. Those will probably get closer and closer.
I definitely agree. And we are seeing more kind of, I wouldn't say dependency, but certainly the importance of the NIC in the entire solution. I mean, you and I mostly focus on the fabric, of course, but equally important people. Don't forget about the fabric. But NICs have become a lot more important. Like I said, with RDMA becoming kind of the way you do storage, the way you run some of kind of these distributed HPC clusters, the NIC has become very, very important, and its ability to play nice with the network, like PFC and Ekin and Beacon and all these kind of, hey, slow down, stop sending because I'm saturated. They become more and more important once you're dealing with like memory pointers, right? Because now you could argue that applications could evolve, and they probably are. I mean, I don't develop applications, so I don't know for sure, but I would say applications themselves are evolving. But certainly the x86 architecture is not. It's not going to handle well trying to write memory somewhere and have that write get lost, because typically it's all in a closed system, and that very rarely happens unless you're having like parity errors or something like that. That's why we have ECC memory. So, yeah.
But Intel also advertises their smart FPGA based NICs as being able to enhance other types of workloads, like more telco type workloads like virtual EPCs, VBNGs. I don't know exactly the intricacies behind how these FPGA enabled smart NICs would really enhance that. But they do advertise it in their marketing. It's all over their marketing, I guess.
Yeah, I mean, if we were like, kind of speculating here, I think there's a few obvious efficiencies. I don't know if Intel can necessarily claim them as kind of being their own, but doing things like GTP, in-cap, and decap in hardware is, like you mentioned, we have like, packet core was moved, I should say. It's not, you don't really buy hardware appliances for packet core anymore. It's all virtualized and it's now moving to containers, and GTP, in-cap, and decap is expensive. So doing that in hardware definitely makes sense. I think doing things like NAT in hardware makes sense. And these are all things we do see in telco.
Maybe 128T can leverage some of these smart NICs.
Yeah, I mean, it's why I brought it up. Right? Like I see that as kind of like an obvious next step for them. The problem that they might find is smart NICs, at least right now, are pricey. Like I guess we haven't figured out how to fab them in high enough volume, or I don't know, maybe Mellanox was just dominating the market because they were first to market with their smart NIC. And it's worth saying there are other contenders, like Broadcom has a smart NIC now, their Stingray architecture. So there are others out there, but they're expensive. They're also power hungry is the other side of it, right? Like some numbers that I saw floated around, and this is not the case for all smart NICs, so take it with a grain of sand, but like 300 watts for a NIC. Like that's
a NIC?
For a NIC.
Yeah, that's significant.
Yeah, and these are like the FPGA, you're running a bunch of crazy like workloads on them type of NICs, right? But that's insane. You imagine you have an entire rack, you've got 2 NICs per servers, you've got like 24, 30 servers per rack. Yeah. And each NIC's pulling 300 watts?
And that's just your NIC.
And that's just your NIC. Yeah, then you've got your CPU, you've got, the actual cooling for the rack. I mean, it adds up. It almost gets to the point where you're better off buying like a more capable top of rack and doing all of those kind of hardware functions on a more expensive top of rack.
Dare you try and move this back to the top of rack, Bruce?
We're all going back to the fabric, baby.
All right. I think we're good. We can move on to the final one, unless you have something else to say about
No, I don't.
This
I think
one.
it's going to be interesting
We
to
should
see
move
how
along.
how's. I'm actually really glad to see it. I really am. I think competition for all areas of the data center is needed. Having monopolies is not good for anybody. So
Right.
I think this is just welcome competition. I look forward to seeing what AMD does with the acquisition. And like you were pointing out, if there are any kind of specific synergies they're going to get by having like a Xilinx SmartNIC along with like a, I don't know, like a Ryzen Epic and probably not the GPU side. I don't know if AMD's really targeting GPU for kind of ML AI workloads.
I think
just
they are
yet.
now.
They are? Okay.
I think some of the big Navi stuff is actually pretty performant at that area from what I've read at least, but
Cool.
we'll see.
AMD world domination. It's not about Nvidia anymore. All right, let's move on. And I don't think we're gonna spend too long on this next acquisition. So if
No.
you have held on this long, don't worry, guys. Just a
I'm
little
sorry.
bit longer. Marvell acquiring Inphi. So just some rough details on the deal. $10 billion cash plus stock. I don't know the split. I didn't care
By the way,
enough to go
I
and
think
look.
I think that $10 billion is not even official. It's rumored, right? I don't think that's
Oh,
think it's
really?
come out. I don't think it's been announced. I think it's like one of those numbers that was people are estimating, at least from what I looked at. But I looked at this when the announcement was made like 2 weeks ago, I think. So
I see.
it's very possible that between then and now, it's actually been, the numbers have been
Finalized.
released. Yeah.
Okay. I mean,
Let's go with 10 billion. Let's just go with
I'll
that.
add a star next to my notes.
Yeah.
So Inphi was founded in 2007, based in Santa Clara. I actually don't know where Marvell was based. I know they have a big office in, I guess it's Santa Clara. I drive past their
they do.
building pretty
I was
often.
going to say, I drove
Yeah.
past it the other day, so I know they have a pretty big building there.
Yeah. Inphi is kind of interesting because unless you deal with optics or very much at kind of the hardware layer within like a switch, and I'm thinking, like SerDes, things like that, you probably haven't
never heard of them.
Yeah, exactly. You probably haven't heard too much about them. So they deal a lot with like DSPs or digital signal processors. These are little chips you see inside optics, retimers, gearboxes, all the components inside the switch, other than the ASIC itself, basically.
Right.
Is what they deal with. So that's the end of my notes.
And I will add absolutely nothing.
Yeah.
There you go. Good purchase. 10 billion sounds pretty good. 450 million sounds pretty good.
Yeah.
And my purchase-o-meter, that's a solid 9 out of 10 purchase.
Purchase-o-meter. I like it. We might have to continue that for future episodes. 9 out of 10 on the purchase-o-meter. I like it. I don't know how much this conflicts with Marvell either. Like, I didn't look too much into it. I know Marvell has kind of typically been known for I guess memory and for Cavium, of course. We didn't even talk about Cavium up until this point throughout all these CPU acquisitions. So I think that's a little telling. I know
We are the authority on.
we are. Absolutely.
So the fact that we didn't mention it and the fact that we're the authority on this topic just really tells you a lot about Cavium.
It really does. Although they had enough money to make a $10 billion acquisition. So
That's true. So they're probably okay.
Yeah. I mean, all in all, I'm sure it's a fairly synergistic acquisition for Marvell, given that they've mainly focused on, I guess, the CPU and memory aspects of things, and not so much on things like SerDes and modulation for SerDes and all that good stuff.
Super exciting things, like super exciting.
Yeah. I mean, it's a pretty foundational technology, right? I mean, we'll take it for granted, but that 32 by 100 gig switch probably has I mean, it's got a bunch of SerDes in it, and they're very important, especially driving them with enough power at a high enough speed, with enough power, I guess, that you're not creating noise. So it's a super complex. Like I said, we're not hardware guys. We don't know what we're talking about. But
and we shouldn't discount how complex it is. No, absolutely not. But
Yeah.
I mean, neither of us can speak that smartly about it. So
Indeed. We'll have to bring on a hardware engineer, and they can give us like a
that's a good idea. We should actually.
On why Inphi is a stupid or a smart acquisition for Marvell, and how complicated SerDes really are. And retimers and gearboxes and all that good stuff.
Gearboxes and super exciting things.
Alrighty. Well,
All right.
think that closes out this episode of Expedited Forwarding. If you've held on this long, thank you for your attention. We hope this was interesting.
Yeah.
If you didn't, then you can't hear this. So
too bad.
I was going to say something stronger, but too bad works. Alrighty. Let's cue that outro, and we will catch you in the next one.
Have a good one.
Hey everyone. Thanks again for tuning in. As always, please do let us know any feedback or criticisms you may have. We can be reached on Twitter, YouTube, or our website, ntwr.kn, where you'll find this episode and many others posted. For those of you on YouTube, if you liked the episode, please hit that thumbs up button. And if you didn't like the episode, feel free to hit the thumbs down button twice. On a side note, you know those cliche, "these are our opinions and not that of our employer" statements you hear all the time? Yeah, we unfortunately have to make one of those. The benefits of working in the industry we want to publicly have an opinion about. We've done our best to remove bias, but we're only human and we make mistakes just like you. Thanks again. We'll see you in the next one.